Ezeoguine, and I am an MSP studying at the Federal University of Technology, Owerri, and I'm glad to be here.
Thank you very much, and you are welcome. Busirah, you can kick off kindly.
Okay. So can we all like see my screen right now?
Yeah, we can.
Yeah, I can see it.
Okay, so basically I will be talking on about like different tools and also the workflow for a machine learning project. So for tools that one can actually use for machine learning, one is Visual Studio Code. So you can have your model trained on a Visual Studio Code, and also Visual Studio Code gives like room for like different extensions. So right now you can run your IPython notebook, Jupyter notebook on Visual Studio Code, and you can write like a. It depends on what you're using for your machine learning. So you can write like your native .py.js code in Visual Studio Code. So for Azure Machine Learning Studio, it's um, it's a tool that you can use to build your experiment, your models end to end and deploy. So that's one really great thing about Azure Machine Learning Studio. It gives room for you to import like an existing experiment or you build from scratch and also publish as a web service. So Azure VM. So Azure VM is like an instance of a computer on your Azure portal. So the great use of this VM is like for big projects. Probably you have a model that can take several hours to run. You can just have it as a background script running on your VM, and you don't really have to worry about my system can go off or maybe internet failure. So once you have the instant VM instance on, you can just have your model run and yeah, good. And Azure VM can also be used for deployment. So you can have your app deployed on it. So for Azure Notebook, so Azure Notebook is like the normal Jupyter Notebook. So and also this is connected to your Microsoft Azure portal account. So you can do all sorts on Azure VM too. I mean on Azure Notebook too. So the next one is Azure ML Workbench. So Azure ML Workbench is hello? So this also provides a platform for you to train your model and also deploy your model. So it's for me, it's more useful for model deployment. So the next on this list is your Jupyter Notebook and also your Jupyter Lab. So these two are kind of really similar. The only difference between the two is that you have your with Jupyter Lab you have your notebooks well like structured and it's the UI is like I provide the UI to Jupyter Notebook. So that's like one of something about Jupyter Lab. You have all your tabs well structured and you can actually split screen, do all sort of do stuff you can do on Visual Studio Code, like you splitting your screen on the Jupyter Lab. So that's one thing. And also now you can integrate Git to these notebooks. So as like I think I noticed that one of the constraints for most machine learning people is having to like upload their notebook on GitHub. So most of us like just have a notebook on our local environment. So one good thing about like this notebook is you can integrate Git to it where you commit, you can push your code from it. And also the same thing goes for the VM, you can connect your GitHub to the VM and you push your code to GitHub straight from the VM. So the last on this list is Anaconda. So Anaconda is like a package that comes with a lot of built-in Python libraries or R. It depends on what machine learning tools basically. So you have all those packages on Anaconda already. So Anaconda is like an environment itself where you can launch your Jupyter notebook. It can have your spider launch from it. So it's a tool that most beginners will like want to check out because it's more beginner friendly and it gives room to also play around with conda terminal syntax. So I'll be moving forward to the workflow now. So for every machine learning project, this is like a workflow that most this actually like applies to like most machine learning projects. So what I have on the first tab here is the process and also the tools you use for such for the process. So the first thing on this uh, workflow is data gathering. So for any machine learning project, the first thing you do is okay, what do I need to train on? That's your data. What kind of data do I need to gather? So that's the first question. So even for like machine learning competitions, the first thing you do is you download your data. So that's like part of data gathering. So on Kaggle, you have to like download your data, unzip it. So if it's a custom project where probably you're trying to predict the stock exchange price, that means you have to like get your data from a source. So and there are different processes like to that. I mean different process to that. So you can have your data in form of questionnaire or you scrape website. So in form of questionnaire, that means you most times questionnaires comes in like a manual kind of format where you have to give people your form to fill just to know their opinion. Then you can now do data entry on Microsoft Excel. So web scraping, for web scraping, you use your preferred programming language to scrape websites. So for Python, you can use Beautiful Soup, Strapi, Selenium for scraping your website. Then for JavaScript too, you can use Selenium driver. So and also you can use R. It depends on the programming language you're comfortable with. So and also you have documents and record. So you can have like a bunch of documents that you actually probably want to perform a test classification. You have a test classification problem or topic modeling. You can use documents and record for that. Then of the observations too, and we have interviews. Probably you've interviewed people. You have that record stored already, and also you can have like a survey, maybe an online survey. So tools for that. So I mentioned Python, R, Microsoft Excel. You can have your survey hosted on SurveyMonkey or any other survey hosted platform. Then also you can have it in a printed format. That's in case of a questionnaire. So most questionnaires comes in like a form kind of format where you have to fill your opinion in the form. So the next phase is data cleaning and analysis. So data cleaning and analysis is okay. I've gotten my data, but yeah, you scrape the website. You have no access to the data to say, oh, this is a missing value. I have like this very big, large number here that I need to remove. So that's what. So data cleaning and analysis is a phase where you get to like understand your data. You actually be able to visualize the data and get to know the data better. So it's more like okay, you're getting to know someone better. So you try to like ask questions. you try to like look at this person physically, that oh, I think I like this person's eye. So for that, that's it for data too. So you get to check the length of the data, you check the shape, the columns you have, you check for missing values, you check for duplicates, you check for outliers. Then once you okay with those things, that okay, I think I'm okay with this. So that's when you can now start. Okay, how do I analyze this data? So that's when data encoding comes in. So data encoding is like you need to change the data in a format that your system, your machine, your computer can actually understand. So, and that format is basically like numerical format, because the your computer cannot understand a string kind of format, or probably have an object format. So your machine can only recognize a certain data type kind of. So that's when you have to. So if you have a text document, that's when you start thinking about vectorization, word embeddings, bigram encoding. Then if you have like normal uh, categorical data, that's when you start thinking about label encoding. That's when you convert to zero ones, and for a larger category, it is advisable you use like a one hot encoder. So that kind of creates extra columns for you to uh, have your data stored in a machine readable format. So, and also for image data, basically the way your machine reads image data is actually it reads it in a vector kind of format, not the image you see. So it treats it like, oh, okay, I have this full image. Then can I break it down into pixels, into vector? So that's how your machine sees it. That's when you cannot do all sort of transformation on your image data. So, and also standardization also helps in putting balance to your data basically. So also data manipulation involved you trying to find a pattern in your data. So that could be like feature engineering, or you. So basically, it's more of feature engineering, because you're trying to see different things you can bring out of this data. Probably you. So this is a process. Probably you have a date time column. You can actually extract maybe day of the week from that date time. You can extract months. You can extract year. You can extract the week in a year from the date time column. So that's you creating like new columns for your data. So the next thing is data visualization. This data visualization is like very important in data analysis, because you get to visualize your data. You get to understand, because data analysis is more of you understanding your data. You get to see covariant variable and all. So you get to see like how your data relates, and also they okay, for something like outliers, with visualization, outliers are more visible. So you get to see a lot of things from the visual. So it's like a very important process when you're building your model. So it's one of like the most important step. So you need to visualize your data to get to see a clear picture, and also how things correlate. So tools for that. So you can use Microsoft Excel for your data cleaning and analysis. Microsoft Excel is a very powerful tool for data analysis. And also you can use Microsoft Power BI. That's like a very like really cool tool for visualization, and also your data cleaning and all. So uh, pandas, if you are more interested in, okay, I want to write my code, I need to because one of the difference between using a programming language and also having a well packaged app like Microsoft Excel, Microsoft Power BI. Is just with a programming language, you get to customize your output the way you want. So you can, like, it's more flexible when it comes to, okay, I want my borderline to be blue. You can customize that with your programming language. So that's like the only edge or using a programming language as over having a built app. So with pandas, you can do like all this. You can clean your data, you can analyze your data, and pandas also has some visualization um, APIs you can use. So there's another one, Dask. Dask is really good when you're handling like a very large data set. So pandas cannot handle, I think, the pandas cannot handle a data that's more than I think 5 gig. But when you have like 6 gig upwards, it's better use something like Dask for your data cleaning and analysis. So the next, after cleaning your model, I mean your data and analyzing it, you've done your feature engineering. The next step is, okay, I need to train my data. I mean my model. I need to train, and basically what training means is the machine is trying to learn from the pattern. So this is, for me, I visualize model training in a graph format. So this kind of creates thousands of relationship between your data, and try to like find a pattern, so that when you bring in a new data, it can actually predict, because this machine learning prediction is not magic. It's just the machine trying to learn from pattern, then predicts based on what the machine has learned. So the first step in model training is you have to understand your task, because you can't just say, oh, I need a machine learning algorithm to train my data. You need to understand your task first. So understanding your task is means, okay, they have a classification task. Is this a regression task? Is this a clustering task? Or probably I just need to analyze. That means you don't need to train your model if you're just analyzing. So you need to understand your task very well, because that will actually that will determine the kind of algorithm you use, your approach, and all. So the next step is you identify your features and your targets. So that means you're trying to identify what problem are you trying to solve. Okay, I'm trying to actually predict the housing price in California. So that means for any target that I have, so that means what I'm trying to predict is the price. So in my data set, then I can look for price column and pick it out as my target. Or I'm trying to predict people's survival rates. So then you can now check your data to see, is there anything like survival rates or survivor in my column, in my data. So that will help you know what your features are, and what your target is. So from features, you can, so using from your analysis, you can actually pick some important features that, okay, I think this is more correlated to the target. Okay, I provide this because this is the kind of insight I got from my analysis. So that can help you like pick your features. And also, moving forward, you have to split your data into train, test. Sometimes you split into three format: train, test, and validate. So the essence of that is for you to, because one thing about machine learning, I mean model training, basically is there could be data leakage. And okay, you don't training your model, and you could see maybe 90% accuracy, but yet your model is not doing well. Like when you tested it, it was predicting like really really wrong results. So that could be as a result of probably the model has overfitted, or maybe sometimes underfitted too. So that's why you have to like test, validate your data. So that's the essence of you splitting into train and test sets. So one is for training and the other is for validation. Because one thing about your test set is that you for your test set, you know what you are predicting already. So it's more like I know the value is 1. But now when I test this model, will it give me 1? So if I got 1, that means okay, my model actually performed well. But if I get like something like 0, that means I need to check this model, improve on it. So that's the essence. So that's the major use of your test sets. So that's you use it to validate your data. So then the next step is you look for you pick a suitable algorithm. So even though you have a classification problem, that doesn't mean all classification algorithm will work like really good for your problem. So something like you are trying to predict uh, a probability kind of prediction. So probably you're just working with maybe sentiment analysis. So I like not every model will work for that. Like in the real sense, when you study all these algorithms. So for that kind of problem, you might want to use something like naive Bayes or algorithm. So, but that's the reason why you need to understand all these algorithms, especially the mathematics behind them, so that you can actually visualize how the algorithm will hold the data and we try to like find pattern and all. So that's when you know that this most likely won't work for my uh project. Then the next step is you fit your data into the algorithm. So that's when the training starts. So that's you loading your data, the data you've splitted into your train targets. You have your featured and your target. So you fit into your algorithm. So once you're done training, the next step is how well it's like what's the performance of this model. It's something like most people want to know that okay, I'm done training, what's the next thing? So that's your model testing. You get to test with different so for me, most times I try to like, so in case you have a classification problem, so you use different metrics to test that. In case you have a regression project, you use like really different metrics to check that. And most times there's always this saying that accuracy is not the best metrics to test your model. So even though you're testing for accuracy, you need to check for other things too. So in the sense of recall, precision, or for a regression model, you can use the RMSC value, your mean squared error. So that will actually help you to understand. Okay, this model uh, performed really well. So for a classification kind of task, one really good metrics I use is conversion matrix. So conversion matrix tries to like tell you the number of predict actual true that were predicted correctly. So that will give you like a proper view that oh, I have 1,000 ones and my model was able to predict just 10. So like without you going further, you know that model needs like some maybe tuning or something. You need to improve on it. But when you get something like 900, that's when you know oh cool, I can now proceed. Even though I still need to improve on this, but this is something that I can show people that have worked on this. So the next thing is your model serialization. That's when you okay, I'm done training, but the next time, okay, I'm done training and okay, I want to switch off my laptop probably due to flat battery, or I just need some time off. So that means, do I have to like train all over again the next time I open my laptop? No. So that's when model serialization comes in. So this serialization is just basically you keeping track of those parameters and trying to couple your trained model into a format you can always load and continue training or use during deployment. So one of the formats you can actually serialize into is Pico. So there's a Pico library you can use, and scikit-learn also has a Pico API. So there's H5. You can serialize your model in H5 format, and JSON. You can serialize your model in a JSON format. So JSON format most times that works for probably you have a lot of parameters you need to serialize. So that will kind of serialize it in an object kind of format. So you have HDF5 too. So for model training, model testing, model serialization, that's for me. I mean, for most projects, it's an iterative like process. So most times when you train, you have to test. When you test, you have to serialize your model. When you need to improve on this model, you go back to training. Probably you perform some hyperparameters tuning and stuff on the model. Then you test again, then you serialize. So serialization is like, okay, I'm done, let me save this data, I mean let me save this model. So it's more like a loop. So anytime you train, you test, you serialize. So that means you've passed the process of data gathering. You have your data already. So most times it's a cycle. And tools you use for this is you use scikit-learn. Like for most machine learning person, like even if you're just starting out, you use scikit-learn. TensorFlow, you can use it for machine learning projects, you can use it for deep learning projects, even NLP. Or detection is a tool you can use mainly for majorly it's for object detection. So Onyx Runtime, it's a tool from Microsoft. So Onyx Runtime has like a lot of features. You can use Onyx Runtime to convert a serialized model from a format. Probably this model was serialized with PyTorch, uh, and you need to read it with TensorFlow. So you can use Onyx Runtime to do that. So Onyx Runtime is like a very powerful tool. And also there's this PyCarrot. So it's a tool that it started getting popular of recent, and I noticed that it has like most projects, it gives like a more accurate results. And I noticed that the number of users are growing too. So after this, the next step is deployment. So you're done training your model, you're done serializing your model. What's the next thing? You have to deploy this model. You can't just like keep sitting on your computer. Yeah, because deployment is when you actually put it to use. That's when you can connect to maybe your desktop app, or probably you can connect it to your web app, or you can even test it as a standalone API on itself. So the process of deployment involves you trying to, because you predicting on a data means, so I have trained my model, I've serialized the model, but yeah, I can't just bring in just any data. So there has to be like a pipeline to pre-process this data. So there has to be like a step. So probably the data using the text data. I need to convert it to vector format. So that's a step. So that's like the pre-processing part. So then you load your serialized model. So you have your data on JSON format. You can load it, and also the next is to call your predict API. Probably okay from scikit-learners.predict. So that's when you now load your preprocessed data, incoming data. So then you get your output. Then you can now serve that as an endpoint that users can actually have access to. So for that, for deployment, you most times for my deployment, I write my APIs with Flask. You can it depends on your preference. You can use like anything for your deployment. So and also you can deploy on Microsoft Azure VM. You can deploy on App Service. You can deploy on Machine Learning Studio. So there are also like other servers where you can deploy. You can deploy on Heroku. But yeah, these are the Microsoft tools. I mean, the available Microsoft tools you can deploy on. So now I think we've been able to like cover like an end-to-end machine learning workflow where from data gathering up to deployment. So yeah, that will be all from me. Yeah, thank you.
Thank you very much, Busirah. That was a very awesome session. I've learned something that I didn't know. Thank you very much. Now,
Yeah, thank you.
the next speaker is Chuka. Chuka will be taking us through. I think it's data visualization. If I'm not wrong. So, Chuka, can you please check the stage? You are next online.
Right,
I
so I
can hear
want
you.
to thank. All right, I want to thank Busirah. She really did a great job explaining
Yeah,
the machine learning workflow, and that will really ease my job for me. So I think I will start sharing my screen now, and I'll walk you through my slide and then the code. Right, yeah, okay, yeah. So that's fine. I'll begin. So I earlier introduced myself. My name is Chuka, and I'm interested in economic, data science, finance, and adventure. And I'm a student partner at the Federal University of Technology, Owerri. So what I'll simply be doing today is to take you through a linear regression algorithm. So just to show you how to build a linear regression model with Python. And you'll be able to use this model to predict a student's final GP. A student's final grade point. So when he leaves college, what does he end up coming out with? All right.
okay.
Okay. All right. So linear regression. What is linear regression? So as most of you may already know, linear regression is all about finding the line of best fit. So I will show some pictures to support this definition. But you all must be familiar with this equation here. Y is equal to mx plus b, right?
Mm-hmm.
Fine. So in this equation here, y is the dependent variable, m is the slope, and b is the intercept. I would explain more on that later. All right. So now to run or to build a linear regression model in Python, you need to use the scikit-learn library to develop linear regression model. So you need to use the library to import the linear model module. So I to use this algorithm here. Then once you've imported it, you now need to split your data into four categories. So that is the train data set and the test data set, which was clearly explained in the previous session. So what this simply means is that so here we have X train, X test, Y train, Y test, right? So here X train and Y train is simply, so X train here is the features, right? So the features of your training data set, and Y train here is the label of your train data set. Y X test is the feature of your test data set, and Y test is the label. So here, what I did was to split it into an 80 to 20 ratio. I would explain more about that in the code. Then after that, we'll now run the algorithm and fit. So that I try to find the line of best fit with the linear dot fit statement. So yeah, and as was earlier said too, it's very important to visualize our model. So if you look at this next slide here, what do you see? Do you see a negative or a positive correlation? Please, you can unmute your mic and reply. Just
I think it's positive.
yeah, it's a positive correlation, right? Meaning here that as the jump score increases, so yeah, jump is just an examination that most students in Nigeria write to get into federal university. So if you have a high jump score, it increases your likelihood of getting admitted to college, right? So what this shows is that students who, or most students who had high jump scores when they applied to college ended up coming out with a high GP. So that is just what this tries to show. But of course, there would always be some exceptions. But as you can see, this shows a strong positive correlation. So now, if you look, you can see that the first picture by the left, that is this, is a positive correlation. Then the next is negative. Then the third one here is no linear relationship, meaning that you should find maybe other algorithms to better predict it, because you can't model this data with a straight line. So you can also work with a multivariate linear variable. So what this means here is that we are going to be working with data in four dimensions. So as this picture shows, you can see that we have four coefficients, right? So we have 4 lines here with 4 different slopes and 1 intercept, which we are also going to see in our code when we are going to see that we're going to have 4 different coefficients for our 4 different features and one. And as earlier discussed too, there are different. You can kind of see the metric of your algorithm. So to know how well your thing performed, your model performed, there are many ways to quantify it, right? So we have mean square error, root mean square error, and mean absolute error. So mean square error is just kind of it just helps you to quantify your accuracy without trying to look, without being concerned about the scale. But when I use something like mean absolute error, when there's a change in scale, kind of affects the reading you get. So mean square error readings are kind of scale independent and are preferable to absolute error. All right, thank you. So what I'll do now is to share my Jupyter notebook with you, and I assume that most of us here already have a Jupyter notebook installed. So let me see. I need to. Can you see my screen? Can you see the Jupyter notebook?
Not yet, Chuka. I think it's loading because I can only see the last slide from your PowerPoint presentation.
Okay, let me see.
Or you can cancel sharing and then you reshare again.
All right, that's what I'm going to do.
Okay.
Chuka, you may need to share your complete screen. Share your complete screen, then it will be visible.
Okay, yeah.
Okay, let me see. So like my desktop, right?
Yeah, share the first. Yeah, it's visible now.
All right, so let me see. So you can see my complete screen, right?
Yeah.
Okay, okay, that's better. So let me see.
Yes, it is visible now.
Okay, so let me just um, all right, so let's get started with the code. So first things first, there was a file. I'll see my Jupyter notebook.
Yeah, we can see you.
All right, yeah. So there was a file that was shared on the Teams page that so that is the file we are going to be using. So this file is just it contains names of students and their jam scores, whether the smoke whether the smoke weed or not, and their best food and some other. So for us to be able to load this data into our Jupyter notebook, what we have to do is to import the necessary different libraries for us to be able to manipulate the data. So first of all, we need to import the pandas library. So I'll just quickly do this. We import pandas as EB, right? So here you can use any stuff you like. You can, but normally PG is the convention. So we also import the NumPy library too. So I'll just quickly do this. Then now we need to load our data, and our data is in the Excel format, right? So I'll just simply use the pd.read Excel. If you are loading a maybe a CSV format, you would have used pd.read CSV, but here since it's Excel format, I'll use the pd.read Excel. And then I would provide a file path to be able to load this data. I hope so. I'll just provide a file path. I already kind of already checked it. So here is my so normally you can just copy and paste this file path and yeah, you are good to go. So here is my desktop. So now one thing you notice here is that I used the R this in the R before typing this file path. This just because if I type this file path directly, I'm going to be getting so for this slash is more like a special character in Python. So I have to use that R to prevent the error. So let me see how this goes. Okay, so let me see. Okay, so I think it's from this file name. I think what I'll simply do to be fast is I'm going to look for this on my desktop. So you can just search for the file on your desktop. That you can also okay. Yeah, so this is it. You open the file location, then you copy the file path. So go to properties, then you can go to security and just copy this. All right, so let me see. All right, so I've loaded the file into my Jupyter notebook. Now the next thing I have to do now is to be able to view this file, right? And so if you notice here, I loaded this file to a variable called student data. So what I'll just do here is to print the file, so to be able to see it. I just use the Python print statement to print the file. So once I do this, so you can now view the file here. So if you look at the output here, what you see student name, like the name of the student, the state of origin, student jam score, the students department, the students where student lives, whether student lives in the hostel or in the lodge, does the student smoke or not, and then the student best food. So these are the features that we have in this our data, right? Now there are other things too we can do to to look at the data. So we can decide to view the data by only viewing the first 10 rows. So we just use the student data.head. So we can just view the so, just to view the first 10 rows. So if you look at the output here, you see that. Let me just move this. I'll just delete this. All right. So what this shows us the first 10 rows of our listen. If you look at this output here, you can see sorry the first 5 rows. Oh, sorry. So this is 1, 2, 3, 4, 5. Then to view the last 5 rows, we'll use the dot tail. So we'll use the dot tail module.
Yeah.
Yeah. So this will show you the last. So just to help you with knowing with kind of seeing what your data contains. So this is if you can notice that this is 199. So this data consists of 200 rows and 1, 2, 3, 4, 5, 6, and 8. Now to be able to know like how many rows and columns your data consists of, there's also a statement you can use too. So you can use the I think the dot shape statement just to be able to. So all this just helps you with trying to know, trying to become familiar with your data, know what you are really working with. I just try to be fast. Yeah. So you need to just be careful with. So I use student data.shape. All right. So all these things need familiar. So this shows 200 rows and 10 columns. Can you all hear me?
Yeah.
Yeah.
All right. Okay. So I'll be. So now the next you can also do is to kind of get information about the data, right? So more like to know the. So let me use student data.info. So what this simply does is let me just show you something here. So fine. So this shows you that student name, origin state. These are object categories. So yeah, what this object means is that pandas does not really know where to place these stuff, and since they are not integers or floats, it just place them under the object and data type. Because if you notice earlier when we kind of visualize our data, you notice here that all these so let me just show you the slide again. So these are more like categorical variables. Pandas does not really know. So that is why it kind of places it under the object system. Why we have stuff like so here now GP is kind of a float. That is it's in decimal, right? So that is why it is here and also it's a number too. So it's float. So I think that is all. We can also kind of describe our data. So just to know what let me use the student data dot. Now this is very essential and you're trying to be able to get a feel of your data. Yes. All right. So you can see here now that it shows you. So this dot describe actually analyzes the numerical variable in your data, which is the jam score and the GP. So here now you can see the mean of the jam score, which is 248, which is quite fair because I tried to when I was artificially generating this data, I had to make the jam scores realistic and to be normally distributed. So you can see here that the jam score is 248. The minimum is 180, which is actually the minimum jam score you need to get admitted to a university in Nigeria, and stuff like that. But here now you will notice that you won't be able to see things like for the other categorical variables, like maybe the student best food, the student stay in the hostel or lodge. So to be able to view those two, what you do, you use the describe statement, but this time you will just include the object type and founder. So empty dot. So let me see what this if this is wrong. Okay. So I think I'm going to run this on my first so you just have a feel of it. So after this now we move to the next one. All right, so I think there's an error here. All right, so you notice here now that we can also kind of find the counts of the categorical variables. So here now the income, we have 74 lower middle. Sorry. So here now we have 200 counts. We have 4 unique categories of income, and the highest category is the lower income, which is actually what you find now. And the frequency is 74. So this just kind of helps you know and get some statistics about your data. I think that is all about trying to play together. So now let's go to the next talk. And now, so we've kind of explored our data set. We now want to be able to work with it. And so what I'll simply do is to delete this and copy this so that I would lay more emphasis on this data. So here now we have student name, we have origin, we have that is the state of the origin, we have jump score, we have so we have student department, we have residence, we have smoking, and we have students best food. Now if you want to be able, now what you want to predict actually is student's final GP, which is the student's final grade point, given all these features here. So now in this scenario here now, the label is actually this GP here, right? Why the features are other things here like income, best food, student smoke or not, residence, student department, and origin and jump score. So now what we want to predict here is actually the GP. And please, I want to know, are you all following?
Yes.
All right. So the first thing we need to do is what you can call feature selection in this kind of case. But here, so if you look at this data here now, so I just want you to maybe with your just try to look at it and tell me if this feature is important in determining a student's final GP. So is the student name important in determining a student's final GP?
No.
Like, no, okay, fine. So we won't include that. What of the student state of origin?
No.
No.
I don't think so.
So what of the student's jump score?
Yes, I think.
Yes, it is correct. Now, what of the students? So income. So the kind of the income of the family the students come from.
I think it might determine.
Yeah, it determines. So even if it may not be so strong, but there is kind of it has some. What are the students best food?
Pardon?
It does not, right? Does this student smoke or not? Yes. So smoking also determines the student's final grade point. Because that smokes a lot may not. Then does this student stay in the home? And stay in the hostel means which is mostly off campus. You tend to see the night parties and kind of get distracted. So it also has a kind of a correlation with the final grade point. Then department does not really have a correlation with the final grade point. So now with this now we are going to only include the features that we believe would have a correlation. So that is what we are going to do now in this next line of code, which I'm going to type. So what we'll just simply do here is we just still use student data, and we'll now only include those columns that we want to use for our regression, which was the jam score and residence. So those students stay in the hostel or in the lodge, which was also part of what we want to use. Then does the student smoke or not? Does the student smoking? Then what next again did we say we are going to use? I need your input. You can look at the then income. Yeah, we talked about income too. And then what next? So fine, and then we'll include GP. But this is what we want to work with. So we've dropped the other features that are not necessary. So here now, if you view this file that this data set that we just created, you see that. Sorry about that. So I'm just trying to like only the ones that I want here. So now if we print the students now, we'll see that it's going to the columns that we included, which is the jam score, the resident, so this student smoke or not, the income, the student that the family network, family income, then the GPR. So this is what we are going to be working with. Now the next thing we have to do is to now the thing is, if you are running a linear regression model, you won't be able to work with categorical data. So we have to convert all these categorical data here to kind of, we need to encode them, right? And this was clearly explained in the previous session, so I'll just simply write the code. So to be able to do this, we have a function, or we have a library called label encoder in scikit-learn. So I'll just import that library here. So I'll just from scikit-learn.prepro. Okay, pre-processing or pre-processing. Okay, yeah, that's scikit-learn.pre-processing. So we import label encoder. And what this simply helps us do is, so here now we have like lodge and hostel, right? So it can decide, okay, fine, let's hostel be 0, let's lodge be 1. Yeah, let's no be 0, let's get be 1. Yeah, let's upper middle income be 0, 1 be 1, and so we'll just, first of all, let's start by doing for resident, then we'll now do the encoding here. Yeah. I'll just change everything later. So I'll just put back the resident again. Boom. Because we are working with pandas, and I know this will throw an error. Let me see. So this is student data. Right, so I think this should work. Let me see. Okay, that's it. All right, you can just go through this. In case you see any stuff that is not right, just let me know before I run. Okay. So this number.fit.transform. Let me see if this. Okay, now so we just do the same thing for residents here. Then we'll do the same thing for smoking. So I'll just copy this. I'll copy this, paste it, and change this to smoking. And copy this. And paste this here. I'll do the same thing for income. So what we are doing here is to encode these categorical variables to that they will kind of be dummy variables that we'll be able to run our regression algorithm on them. Let me see what we are going to get when do this again. Let me see. Hopefully this does not produce any error. So let's see. Right. They're saying here that number is not defined. So what could be the problem? Let me see. Okay, scikit-learn. So let me see. So here from sklearn we imported label encoder. Then here what we are trying to do, as I said earlier, is to encode the resident, the smoking, and the income. Okay. I don't really know what's wrong with this. This is just our time. I think it has to come from this. Hello, please, can you all hear me?
Yeah, can you check where you define number?
Number? No, I did not really define. No, this number is just like a scikit-learn.
You did not instantiate the object of level encoder.
Level encoder. So number should have been like your label encoder instance.
Okay, let me see. Let me just see if this would work. Okay, so if
you're not
is not
mute your mic.
Like your label encoder should be assigned to number instance of it.
I did not
To say you can.
So you see, so it's not. I think this is going to be giving you guys the real feel of what it is to actually do this. So just put you once in a while. So let me. So you see, I did not even define the number variable. So that was what I missed. I think this should work now. That's even me. I think this should work now. All right. This would work. This one is just more like a yeah. What I'll do is to I try to be doing this in real time so that you kind of have the feel of what it is. Um, Lord. So what this thank you very much for the input. I really appreciate it. So what this is kind of to categorize these variables, right? So here now we have resident. So postal is zero, lodge is one, and no is zero, yes is one. They're the same. So it kind of categorizes the variable. So once we are done with that, we can now begin to um, we can now begin to work with the linear regression. So you can now start doing the kind of algorithmic part of this whole stuff. So I'll just simply do is to insert as well. So let me just do a few importation here. I think I've already imported circuit. So we will need circuit length to select our model. Then we would also import so from we'll just import model selection to help us select the linear model. And after this, we would now from circuit length, we'll now import our so we import the linear model. So after this, to now if you can remember earlier, I said that after working after this shape model, so we would import equal to help us save our model when we are done. Yeah. So now I also want to just tell me. So what are we trying to predict from this data? What are we trying to predict? If you are following.
The GP.
Yeah. So we are trying to predict the final grade point. So we'll just kind of create a variable that we'll call predict and do what we are trying to predict here. Yeah. Okay. Now, remember that I mentioned something earlier about your training data and your testing data. So yeah, now let's that's for one. Now X here now is the feature. Now what is a feature? A feature is a kind of the input per se. So if you look at this data here now, the feature of this data now is the jam score, the resident, the smoking, and income, right? So these are the features, and the label is the GP, that is your output, what you are trying to predict. So here now you have to define the feature, that is the input. So we just use the np.average statement and do that. So and that means for us to define the feature, we have to drop the label, right? Yeah. So what I'll just do, I'll use the drop. So student data dot drop. And what am I dropping? I'm dropping GP, which I equated to predict. So I'll just use predict direct. Okay, I think so this is fine. And since we are dropping the row, just without the column, we just create one beside it. Yeah. So now this is the feature. Then we'll define our label. So what is our label? Our label is just the outcome, right? So our label will only consist of one column. So we'll just do this. This should work. So let me just be fast. I'm going to do. All right. So this should work. All right, so we defined our feature and our label. Let me see something. Okay. So all this stuff sometimes. So you have to just be familiar with these things. So we imported scikit-learn model selection, then we import linear model, import pico, set our label, then kind of define our
Should be
features and label.
model underscore selection.
Model, yeah, underscore selection, yeah, I've made that change. Thank you very much. Okay, so what next now? We now need to define our now need to kind of split our different into test and train. And to do that, what we'll simply do is just do X train, X test, Y train, and Y test. All right. So once you are done, you use this. So sklearn has a module that is called model selection and train test split. So if you are using an IDE like maybe Python, I think it helps with completion. I think Python notebook also helps with that too. But you need to enable the feature. But you just type it so you kind of familiar with it. So we use the Pinterest split, right? And then we would impute our feature, our label. Then how do we want to split this? So we want to split it into that. So 80% should go for the train and 20% should go for the test. So we just use 0.2. So let me just. So what this means here is that yeah, I have explained this before. So X train, Y train is going to be 80% of your data. X train, Y train, yeah, Y X test, Y test will be 20%. And now why we do this is so that you'll not be able to, because as I was earlier discussed, if you kind of train your complete data, your computer is very good at kind of memorizing stuff, right? So it will just kind of memorize this label and spit out the answer for you and give you 100% accuracy. So you want to kind of hide some segment of your data from the training algorithm, so you're able to test it and see if it actually did a good job in trying to develop a model. Many people, if you get any error here, it's fine. So no error for the meantime. So what is the next thing we are going to do? Now, so linear is a variable. You can use any stuff here. So we use the linear regression. Regression algorithm. I'll just linear regression dot linear model dot linear regression. Okay, yeah. So this is how you call it, right? Yeah, so because we are trying to run a linear regression algorithm on our. Now the next thing you are going to do is to fit. So to find the line of best fit. So remember in the slide I actually showed you I showed you three kind of three graphs and showed you how. So a line of best fit is more like a line that kind of connects the most amount of data points. So you can actually write a code to do that part for us, and we use the linear dot fit. So how easy this thing can be at times. So if you now are trying to fit, so since we are only working with the trained data set, so you're only feeding the trained data set into our model, right, into our algorithm. So we are going to only key in the X train, which is the feature of the trained data set, the features, and Y train, which is the label of our trained data set. Okay, fine. So now we've found the line of best fit. Now see, if you want to see how well this stuff performs, now you can just find a variable, call it accuracy. I want to see how well it performed. You use the linear dot score, right? So now what this does, I'm going to explain how this actually works so that you'll be able to kind of have a feel of it. So let me see. So now what happens here, now you've trained your model, it has kind of seen some correlation and stuff like that. Now we want to be able to score your model, right? So now the algorithm does not have access to this white test. What it does is it predicts. So there's more like an X. So it predicts what white test should be, right? And scores it against the white test. So it kind of predicts. So this X test here now is your features without a white test, right? So it kind of provides values that it has predicted for white test. Then now checks it against the actual white test to be able to like know how well it performs. If I run this now, let me just print what we have. So you'll be able to. You can see now this thing performed quite okay. Is 68.9% accuracy. So which is not too bad for a simple model like this. So what this means is that 68.9% of the time it was actually correct in predicting the actual white test, right? Good. And so now we've seen the accuracy. What next? Let us be able to because there is no point in just using a model without. Let us be able to test our model. But before we do that, so let me just let me show you the coefficients of this stuff. Remember that I mentioned something about coefficient and y is equals to mx plus b, where m is the slope, or you can say the coefficient. So if you want to just see the coefficient, you can just do something like this. So I think what I'll just do is, so you use the linear dots. Linear dot square to view the coefficient, then to view the intercept. So here now, intercept in y is equals to mx plus b is the b, right here. So the intercept on the y-axis, if you say two-dimensional stuff, I'll just do basically the same thing. And then I'll use linear dot intercept. So this just helps you see positively correlated to your label or negatively correlated, stuff like that. I hope this works. Doesn't work. Okay, yeah. So you see, so here now we have 4 coefficients, right? And we have one intercept, which is so here. I think this is for So this now is negatively correlated, negatively, positively. Yeah, that's basically it for that. So now we've been able to build the linear regression model and stuff like that. Let's actually see what this algorithm did. But then you are going to notice something here. If I run this cell again, so if you can look at the accuracy is 0.638. If I run this again, it changes. It now decreases 0.596. 0.599. So here the even 0.39. See, so the accuracy fluctuates a whole lot. So that's why we have maybe because this simple model. So it's a model maybe like image classification model and stuff like that take hours or even days or even months to run. We don't just want to lose a valuable model. So that is why we use the echo function to save our model. So to do that, what we will just simply do is to include it here. And I think in 2 lines of code, you should be able to do that. So how we will do it is quite simple. I'll just go through it quickly. So let me see how we do it. Okay. So what I'm going to do is I'm going to do in this pickle, we use pickle dots. Let me place it here. The accuracy. All right, so this will be best place to place it. Now, what this line of code simply does is to create a pickle file in our computer so that it saves our model for us. So let me just call that file student data models. So I create a file and I just need to have the pickle extension. That's what I wanted. So what is that? So when I use WB here, WB just writes binary. So I'm trying to just create a file, and it does it. Just opens the file like this. So as what we call pickle dump. So it kind of it's called serialization and serialization stuff like that. So we kind of dump the model into the file that we created. Understand it that way. So we use a pickle dump. Here, linear is the model that we created, and yeah, so this is it, right? And once we've dumped, you want to now like load the model. You now use the just use the variable pickle read, and then you in the file, so which was student data models. Then data models. All right, so that's pickle, and then we are reading it around. So we are reading to binary, so we use RP, and so this is not how it's supposed to be. So yeah, we just so this should fine. Let me see this along without error. If I was using like maybe Python or you'd have been able to see the file that. So what this code here now simply did, this one I highlighted here, it created a file called a pickle file called student data model, and wrote this the model to the file, and then pickle read open kind of. So if you start to be running this algorithm, you can just simply use this pickle read equals and open the saved pickle file and then load the model to your return notebook. But then if you remember earlier, each time I ran this model, I kind of had different accuracy. So if I want to be able to pick my best the best accuracy, I can simply just use the for loop statement. So what I'll do here is I'll just come here and use my for loop. So I may just define the variable that I'm going to be saving. Let's call it best. That was one. So I can decide to use my for loop for I in range. So if you want to be run like, let me say 100 iterations, that you get your first two. This is it. So we just kind of make it. All right. So now we use our if statement here. So we do if accuracy. Now what this simply does is I initialize best as 0 right here. And here now, I know that my accuracy kind of fluctuates. So I want to be able to pick the best accuracy and save it to my pickle file so that I'll always be working with the best accuracy. So that's what I'm just trying to do here. So if accuracy now is greater than best, so what is this going to do? It's just going to save, it's going to replace this 0 here with the, with what that accuracy is. So that is what this is simply going to do. So it means that if accuracy is greater than best, let best now be equal to accuracy. So I like to update the value of the best. And yeah, so I think we'll just and then let me see what's going to happen. So we are going to see what the output will be like. Sorry, there's an error somewhere. Let me see. Okay. So Python was with indentation. I believe that most of us are already somehow familiar with Python. We had an earlier session on that. So if you look here now, you see that, okay, let me print this accuracy that will have a feel of how this stuff works. So look at in this model around 100 times, right? And we have different accuracies. And so the best accuracy here is 0.73. So at least we want to be working with the best, which is 0.73. So it saves this best model to our students and data model. So at each time we want to, predict or test, it gives us, we are working with the best model. So that's what this just simply does. So once we are done with this, we now, so this already saves So we can now just comment out this and so I think this would work. Actually, there are better IDEs to this stuff than Jupyter. The Jupyter notebook helps with kind of the graphing. So let me comment this out. All right, so if we run this again now, we're going to notice something. You might here now the best accuracy was 0.73 because that is the best I saw. But let me run this again and see what the accuracy is going to be and explain something to you. Almost done. So now I'm getting 0.67. So why is this lower? So why this is lower is simple. Now remember that each time I run this code, what this train test split does is it randomly places 80% of the data in the train data set. That is what we use to train, and then 20% on the test, right? So so you can only get the same accuracy on the model when you use the same data. So long as that data changes, the accuracy will change. So if you want to only use the same train test split to be able to maybe predict or stuff, that means you have to do something different. So you have to just maybe define this. I think I call it, let me say, exact data. So that you always be getting that your best accuracy. If that is what you want. For reasons, so that instead of you to work with this your score. So you to score. Let me see. What's my score? Okay, I said to score with this. You just score with the exact. Yeah, I'll just replace this with exact. Yeah, I need to run this again. Okay. Let me see. Current accuracy, all right? So let me see what I have here. Just bear with me for a minute. Okay. I'm making sense. So all right, so this should work. Let me just comment out this again. I will move to the next stuff. I will soon be rounding up. So, what's the problem here? Okay. This is not even making sense. So I'll still put my X. So I'm scoring my X test. If you see I'm doing something wrong, just you can just key in and interrupt me so that I'll not be making some mistakes here. So here, what I was trying to do is to use this exact stuff here. So instead of it to continue like randomly selecting the train and test and data, it will just use a particular selection which was already defined there. That's what I was trying to do. That's why I just deleted this thing. I just use exact. Okay. Let's see this one. I can just print the accuracy to see what my accuracy is going to be. So, oh, this was not the best. So, I had to just run this again to get the best. So what this means is that when you now run this, you're going to be able to get the best model, which of course is going to be 0.73. And you can now save that in the exact. When you now comment out this, you're getting a quite good model with a good accuracy. What I was trying to do. After this, I'll share this notebook with you so you can experiment with this code. No worries, man. Yeah, so this So now we can be able to like see how well this thing performs and visualize it. So to do that, what we are simply going to do is you can just to see the prediction. Okay, sorry about that. To see the prediction, you can just let me variable prediction and then use the linear.predict statement to be able to. And what you are going to predict the X test, which is the 20% of the. So these are all like the 20% of the features. Right? So this is not more like. So this is 20% of our data, which we are going to use for prediction, right? And without the label. So, and to be able to view how well this performed or how close it was, you just use a for statement. And so, the length, so this is more like a list. So, for X in range, length of this prediction variable here, which of course the length is going to be. So, okay, fine. So, just to know if you are following, what will the length of the prediction variable be? That is the list. What will the length be? Can someone just unmute and reply? Let me know if the prediction is the X test, right? So that is the 20% of the data set. So what is the length going to be?
Probably times 0.2. I mean,
okay, yeah, so that's 40, right? 40,
yeah.
40 rows, sorry. 40 rows. So we are just going to print. So what we are going to print here now is what our model actually predicted, which is prediction X. Then we are going to also print what we are trying to predict, the features of what we are trying to predict. And we're also going to print the label, so the true label, the original label, and see how our this thing performed. So let's see. This will go successfully. Error somewhere. What's the error? Prediction not defined. Okay, so what did I do wrong? Let me see.
Typo.
Yeah, I'm trying to look for it. Prediction. Let me see. Okay, yeah, fine, thank you. So there's something wrong here. Okay, X in range. Alright, yeah. So trying to do it for you. Alright, this is fine. So now, if you can look at this now, you see that what our model actually predicted for this student that got a jam score of 242, that I think that stays in the hostel, that smokes weed. So our model said this student to get a GPA of 2.8. The student actually got a GPA of 1.6, which is 4. Okay, if you look at it, 3.6, 3.3 is quite fair. 3.8, 3.3 is still quite fair. 3.9, 4.6. 3.3, so this one is quite close. So this student got a jam score of 181, is in the hostel, does not smoke weed, to the middle class or so. And the actual GPA this student got was 3.40, but our model said this student to get a GPA of 3.32, which was quite close. And if we are working with a categorical lab doc, maybe if we have more like a range like kind of prediction, maybe if it's from 3.5 to 4.5 is going to be 2.1 and stuff like that. I think it has even been more accurate. But this is quite fair for a simple model like this. So I think that would be so. Let's just kind of visualize and see the correlation. Then that will be all for this. I'll just go to visualize. I'm going to use the matplotlib. So I'll just import matplotlib. So dot pyplot. So I'll just import it as pyplot. I think R has a, so you import style. This will be able, this will make you make neat bar graphs. So you want to, so you just create a variable. I call it exam and just use jam score. And then, so here now, just to make the graphing kind of neat, I'll be using the ggplot. And the ggplot, it comes from R, which is also a statistical programming language. Then I'll plot its plot. So I'll just use the scatter. So if you want to maybe plot the so you can use dot bar and stuff like that. And I'll call the name of the data. Then data. So then our exam is our jam score, which will be on the x-axis. So I'll just put it in here. And GP is the what we are trying to is a label. So I'll just put it on the y-axis. I'll just put it here. All right. So I think that should. So now we can just put your label to help So put your label. Just what I'll do here is that I'll do the X label, Y label, right? So what will be on the X axis? The label is exam. That's to help with the readability of the graph. Then what you then now the Y label I'll put Okay, I think this should work. Then I'll use the shoe, the 5 shoe. You send it error when I'm typing pigeons. So, okay. So let's see what we have. Okay. So let me see why it's not showing something. This should work fine. I think it has the picture somewhere, but it's not. Let me see. All right. So if you look at this now, you can see that as so students with kind of higher jam scores, so this 325, they tend to have higher GP, and students with lower jam scores tend to have lower GP. We can even change. So if you want to see the relationship between let me say income and GP, just change this to income. So that was why I created this. And if you run this, okay, so there's nothing like income, I guess. Okay, so just look at the column and let's see what else we have. So here we have income, we have lock, we have smoking, we have resident. So I would come back here and notice here that think what was 3 again? So 3 was notice here that the higher the richer students tend to have higher GP, right? But it's not really a strong correlation. Can also do for smoking, and you can see here that people who smoke, which is 1, tend to have lower GP, but the maximum was 4.0. But people who don't smoke tend to have higher GP. Yeah. So I think that's all for now, and I thank you for speaking with me.